So welcome to Electronics 6 Alive, and you are watching the Digital Electronics lecture series. And today the topic of discussion is that the RS latch using the NOR gates. So in the previous lecture, we have discussed about the this latches. So latches are the building blocks of all kind of flip flops. So it can store 1 bit of data. So that is why it is known as a 1 bit storage cell or 1 bit memory element. So today we'll discuss about this RS latch. Okay, so first we'll see how the RS latch can be constructed using the NOR gates. Then we'll see what is the operation of RS latch using the NOR gates. Okay, so let us start our discussion. So RS latch, it is the simplest type of latch. Okay, this RS latch is the simplest type of latch. It has two inputs that are labeled as R and S, and two outputs are Q and Q complements. So this Q and Q complement are complement to each other. If Q value equal to 1, Q bar should be 0, and if Q value equal to 0, Q bar should be 1. Okay, so both are complement to each other for normal operation of any latches. Okay. So it can be constructed using the two cross couple NOR gates. Okay. So that can be constructed using the two cross couple NOR gates. Okay. So what is cross couple NOR gates? We have discussed in the previous class also. Cross couple means the output of one gate is connected to the input of the another gate and vice versa. So in this case, the two NOR gates are cross coupled means output of one NOR gate, that is NOR gate number 1, is connected to the input of NOR gate number 2 and vice versa. Let us see the logic diagram. So you can see there are two NOR gates. So gate number 1 and NOR gate number 2. The output of NOR gate number 1 is connected to the input of NOR gate number 2. Similarly, the output of NOR gate number 2 is connected to the input of this NOR gate number 1. Okay, so this is the cross couple operation. Basically, this is helpful in locking or latching the information. So that is why we have this type of connection. It is also known as a feedback arrangement. Okay, so it has two inputs, that is labeled as R and S, and two outputs are Q and Q complements. Okay, that should be complementary to each other. Okay, so using the two NOR gates, an active high RS latch can be constructed. So what is active high RS latch? Active high RS latch means if the high value of 1 means high value of R, and low, that is the S value is 0, the output equal to, it will reset the latch, the output equal to 0. Okay, so if this R value is 0 and S value equal to 1, so that will be your set the latch. It will set the latch means this will be 1. Okay, so this is the output, that is a Q. Okay, so the active high value of R and S, that is used to reset. R means used to reset the latch, and active high value of set will used to set this latch. That is why it is known as active high RS latch. Okay, then the name of the latch that I have told you earlier. So it is R and S. R stands for reset and S stands for set. Okay, so this is the logic symbol of this latch. Okay, but the two inputs are this R and S, and two outputs are Q and complement. Okay, so let us see in the next section how this RS latch is operated depending upon the different combination of R and S. Okay, so let us see that. Of NOR gate is that if logic 1 at any input of the NOR gate, it forces the output to a logic 0 immediately. Okay, so let us see how it looks like. So in any input of the NOR gate is your means 1. So suppose we have the two input NOR gate. So this is the two input NOR gate. Okay, so this is suppose A, this is B. So what is the output? A plus B complement. Okay, so let us take A value 0, B value 0, then A value 0, B value 1, then 1 0 and 1. Okay, so 0 and 0, the input of this NOR gate. So 0 0, the output will be 1. In this case, the output will be 0. Okay, in this case, the output will be 0. In this case, the output will be 0. We can see if any input of the NOR gate is 1, it forces the output to be 0. Okay, you can see it has the at least one input is 1, so it forces the output to be 0. This is true for any input. Okay, this is true for any means 2 input, 3 input, all or n number of input of NOR gate. So if any input of NOR gate is 1, if the output would be 0. Okay, this property will apply to this operation of NOR gate. Okay, so let us see. So case 1, we have the case 1 where R value is 0 and S value equal to 1. Okay, so how this condition is called set condition. Let us see. So we are applying R value 0 and S value equal to 1. So R value 0 and S value 1. So the input S is 1 means that if any input of the NOR gate is 1, it forces the output to be 0. So this gate number 2 output will be 0. Then this Q bar is connected to the one of the input of this gate number 1. So 0, then 0, 0 have to be the output will be 1. Okay. So that is the thing. So we are applying now in this case R value 0 and S value equal to 1. So if any input of the NOR gate is 1, so this NOR gate number 2, the input is 1. So it is forces the output to be 0. Okay. Then this 0 comes over here. So 0, 0, the output will be 1. Okay. So this is known as a set condition. Okay. This condition is called set condition. So you can see when R equal to 0 and S equal to 1, the latch output is in the set state. That is Q equal to 1 and Q bar equal to 0. Okay. Let us see our second case. When R equal to 1 and S equal to 0, what will happen? Okay. So in this case, we are applying R equal to 1 and S equal to 0. If any input of the NOR gate is 1, it forces the output to be 0. So this is the 1. So gate number 1, it accepts the input as 1. So this Q will be 0. Then this 0 is connected over here. Okay. So 0, 0, the output will be 1. Okay. So let us see once again. So if, this is the we are applying the value that R value equal to 1 and S equal to 0. So if any input of the NOR gate is 1, so the output is 0. Okay. So this 0 comes over here. So 0, 0 to the output that will be 1. Okay. So this is the called the reset condition because the Q equal to 0. So active high value of that is the R will reset the latch. Okay, so the latch output is the reset state when R equal to 1 and S equal to 0. Okay, let us take out into our third case, that is the both inputs are 0, 0. R value and S value both inputs are 0, 0. So in this case, we have to assume means in the first case we are assuming Q equal to 0 and Q bar equal to 1. Okay, so why are we assuming? Let us see. So R value and S value both are 0, 0. Okay, in this case, we cannot predict this output. Okay, both output we cannot predict. Okay, so we cannot predict this output. Okay, so because if R this value is your 0, so this get number 1, so 0, 0, what will the output? The output will be 1. Similarly, if this input equal to 1, so 0 and 1, so what will be the output? The output will be 0. Okay, so we cannot predict this output. Okay, that is why you have to assume. Okay, so this is the same case also in this case Q1. Okay, so that is why we are assuming this in this case. Okay, so what we are assuming first we are assuming Q equal to 0 and Q bar equal to 1. Okay, so Q equal to 0 and Q bar equal to 1. So this 0 comes over here and this 1 comes over here. Okay, you can see. So this 0 and 1, what will the output? Output is 0. Similarly, this 0, 0, what will the output? The output will be 1. Okay. So you can see whatever we have assumed, the same thing we are getting. So Q equal to 0, we have assumed, we have got Q equal to 0. Similarly, Q bar equal to 1, we have assumed the same Q bar equal to 1 we have got. Okay. So let us see our second assumption. Okay. So second assumption is that the reverse one. So Q equal to 1 and Q bar equal to 0. If both can be true, then only we can write that it is in the same state. Okay. So let us check our second case, that is the Q equal to 1 and Q bar equal to 0. Okay. So that is 0, 0. So R and S value both are 0, 0. So we have assumed this Q value equal to 1 and Q bar equal to 0. So this 1 comes over here, you can see, and this 0 comes over here. So 0, 0, what will the output? The output will be 1. Okay, similarly, this is 1 and 0, what will the output? This will be 0. Okay, you can see this is 1 and this is 0. Okay, so this is why you can see we have assumed the Q value equal to 1. we have got q equal to 1 also. Here also q bar equal to 0 we have assumed, and q bar equal to 0 we have got. Okay. So why you are assuming this q means in these two cases? Because for normal operation of any latches, this should be complement to each other. Okay. This will be complement to each other. We cannot assume q equal to 0 and q bar equal to 0. Also we cannot assume q and means q both will be 1 1. Okay. So that is why this we cannot assume. That is why we are assuming 0, q value 0, q bar equal to 1, and also we are assuming q equal to 1 and q bar equal to 0. So whatever we have assumed, the same thing we are getting. Okay. That is why this state is called the no change state also. Okay. So when r equal to 0 and s equal to 0, the latch remains latched in the last state. Okay. So let us see our last case. That is case number 4. When r and s value are 1. Okay. So where r value is 1, s value is 1. So means if any input of the NOR gate is 1, it forces the output to be 0. So both you can see q and q complement are 0 0. But in for normal operation of any latches, this should be complement to each other. Okay. So that is why this condition is called indeterminate condition or prohibited state or invalid state. So this is the disadvantage of this RS latch. Okay. So when r equal to 1 and s equal to 1, the latch output in the prohibited states. Okay. So let us see the truth table. So for different values of r and s. Okay. So if r value is 0 and s value is 0, we have no change condition. So in order to set this latch, we can apply r value 0 and s value 1. Similarly, this latch will be reset when r value equal to 1 and s value equal to 0. Okay. And 1 1 what we have indeterminate condition. Okay. So that is the thing in case of RS latch. So we have constructed the RS latch using NOR gates. Then we have seen the how it operates with the different type of input combinations. Okay. So these slides are prepared by using these two books. One of the book is from Anand Kumar, and second book is P. Raja for Skytech publication. Okay. So stay connected to this channel. So if in case of any doubt, please free to ask me in the comment section. Okay. So thank you all.